So this is kind of trying to explain the dot product. So pretend there's this one vector right here, vector v, and there's another one right here, vector u, and let me guess, u would be equal to something like 3, oh actually let's make it 4, just to make it 4 comma 0 in the y direction, and v would equal to 4 in the x direction, 3 in the y direction. Okay, now how would you dot these two vectors, and what does it even mean? Now, one of the most popular examples in physics of a dot product would be work, which is the dot product of the force vector and the distance vector. Okay, and work is a scalar quantity. That means when you dot the two vectors, you get simply a number. So number yes, direction no. Okay, just scalar. Now to understand this, I mean, let's pretend these were the force and the distance vectors. 4 comma 3. By the way, it's super weird because I can't see my hands. I can only see whatever the video is showing me, and it's super strange. 4 0. Okay. Now this is a displacement. That means this is where, let's say, this particle has been moved. Okay, so part of this force, remember this force can be decomposed, and let's do this on the side here. This force can be decomposed into its x and y components. This is the x component of f, this is the y component of f. And yeah, I guess by now you kind of know vectors, or maybe not kind of, you know them pretty well. But this f of x part, moves the particle a certain distance d, which also happens to, to be along this line. They don't have to line up this way. But there's also the f of x, f of y part right here, but there's no d in this direction. So so that you put some force in this direction and you moved it this much. Okay, pretend this was let's say amount of money you put in a certain project. Okay, force on some project. So let's say you spent $30 on, let's say, 5 workers. Okay, that's how much you moved it. That's how much you spent. 5 workers worked on this project. Now let's say you had to pay $40 for the workers that would work on this project. Okay, in this case it's 0. But how much did you pay together? Okay, so you see how you're multiplying the x components of the force and the x components of the distance, and then also the y components of the force times the y component of the distance. And to find the total, you'd have to be adding. So you'd be adding 150 plus, well, 0 in this case. So the total would be 150. So you see how the final result only has the number and not a direction. So that would, same in this case, that would be the amount of energy you would spend. You'd put some force, you'd apply some force in this direction, do work for this long, and you'd apply a force in this direction and apply it for this long, in this case 0, but there can be another number, 3, 2, 1, million, whatever. And to find the total, you just sum them. So how would you do that using just math? Now let's say work equals the dot product of f and d. Now what is our f? Our f is 4 comma 3, and our d is 4 comma 0. Remember before we multiply the x components, okay, separately, just like we did here, and we multiplied the y components separately, like we did here, and then we added them. So in this case, that would be 4 times 4 plus 3 times 0, making a grand total of 16. In this case, that would be joules, if force was in newtons and distance was in meters. Okay, so that's how it works. And you can make a general case for a v that had components of vx, comma vy, comma vz, maybe something something. Who knows how many dimensions there were. And you had some u that had these components, ux, comma uy, comma uz, and maybe extended to more dimensions, but 3 would suffice for most cases. Now the dot product of them would be v dot u equals to vx times ux plus vy times uy plus vz times uz, and so on. Or you could probably even make this kind of, it's the sum of the product of v, I, ui, starting at first dimension and ending at some nth dimension. If this makes sense, then it makes sense. If it doesn't, then that's just kind of something I just made up on my own. I hope this is the correct formula. Looks like it would apply to this situation. So yeah, that's the dot product for now. Hopefully that makes sense. Just multiply the corresponding components separately and then add the results together. Just to kind of go over this real quick once again. Alright, thanks for watching this one.